Hello everybody, this video clip is still on chapter 6, okay, and this one will emphasize on the word problems. This one is a continuation of the last clip dealing with the word problem as well, okay. So previously we got two kind of word problem. The first one is that after you read the word, then you need to construct your function of xy, okay, f of xy, without any condition or constraint. Then you are going to find the extremum of this function, okay. So you first finding your critical value by using the first derivative f sub x equals to 0 and f sub y equals to 0. After that you are going to test your critical points, okay, by using the second derivative test. So you are going to find the same second derivative, okay, in the same direction, compete with the different direction second derivative square, okay, as we told you which one wins and all that kind of thing. On the other hand, you may have a problem which after construct a function f of xy, then you also have a constraint gxy equals to 0. So I mean, to solve this problem or to find the extremum of this problem under this constraint, you are going to use the so-called Lagrange multiplier method. To use the Lagrange multiplier method, you are going to construct a capital F, which is a small f minus lambda g. This is a g, the constraint. And then you are finding capital F sub x, capital F sub y, capital F sub lambda, and then make them equals to 0 and solve for the point xy. Don't forget that this point xy, I mean, if you have if you have anything, if you don't have anything attached, then this one is only the critical point for your small f, okay. It's a critical point for your small f under this constraint. However, usually if you attach this kind of thing with the economical problem, then this critical point usually is the one that will make you maximum or minimum whatever you need in that context, okay. So let us look at this example, and this example also will ensure that what you find as the critical point using your Lagrange multiplier, okay, did correspond to the maximum or the minimum that you need, okay. So usually at the end of the problem, okay, if you see this kind of sentence, then you are going to be very happy that, hey, okay, we are going to use the Lagrange multiplier, and after you got your critical point, then that's it, that critical point will be the one that gives you a maximum profit that you need, okay. So let us read together a little bit, okay. So this one, it says that a company has the budget for advertising of 60,000, and it is like X dollars, okay, spent on newspaper, and the Y dollars spent on television, okay. After doing this kind of advertising, then the monthly sale will be this much, okay, 90x raised to the power 1/4 y raised to the power 3/2 dollars, okay. Of course, I mean, you are going to do a maximum of the profit. So what is the profit? So it says that a profit is only 10% of the sale, but of course you need to deduct your advertising cost, right? So you want to determine how to allocate your advertising budget, I mean, either on newspaper or on the television, so that it will of course maximize your profit, okay. So what is your constraint? Of course the constraint will be on your budget, right, usually. So you spend X dollars for newspaper, Y dollars for television, and it must be, you know, cannot beyond 60,000. However, we are not going to use this one because we need to maximize everything, right? So we need to exhaust all the budget that we have, okay. So we will spend it all, and then let's see how we can maximize, okay. So we are going to use the equal sign. However, this one is not exactly your profit, so you are going to look for the real profit, okay? And it says that the profit, it is 10%. So the 10%, it means 10 over 100 of the sale, and deduct your advertising cost. Of course, you are spending 60,000, right? So this 10 over 100 is simply 0.1, right? So you are going to multiply with 90. So it means that actually your profit, okay, it is what? 9 x raised to the power 1/4 y raised to the power 3/4 minus the advertising cost, okay, 60,000. And this is your g, right, a constraint. So it means that your g is simply x plus y minus 60,000, okay? So we are going to use the Lagrange multiplier. To use the Lagrange multiplier, we are going to construct the capital F, okay, which is our small f is a profit function, okay? So you have a profit, okay, these two terms minus lambda of your g, okay? And then first of all, you need to find f sub x, okay? So to find f sub x, this one, it is 9 over 4 x raised to the power 1 over 4 y raised to the power 3 over 4, and then this one as well minus lambda, make it equals to 0. How about your f sub y? Your f sub y, it is 27, because you got a 3, right, over 4, and then x to the power 1/4, okay, and y raised to the power negative 1/4 minus again lambda equals to 0, and f sub lambda, it is simply your constraint, okay, with negative sign, but you are going to make it equals to 0, okay. You guys should, this one, I make a mistake. This is negative 3 over 4. So I'm not so sure whether you guys getting familiar with this problem or not, but this one is actually the one that we did before previously, okay? So we are going to use the same technique, okay, by look at it this way, okay? For example, your f sub x, okay, so let us add one more page. Your f sub x can be written as 9 y raised to the power 3/4 4 x raised to the power 3 over 4 equals to lambda, and then the f sub y is actually 27 x to the power 1/4 4 y raised to the power 1 over 4 equals to a lambda as well. And because this one also equals to lambda, so we are going to switch it a little bit. So for your f sub y, okay, we are going to switch into y raised to the power 1/4 27 x to the power 1 over 4 equals to 1 over lambda, okay. We good. We just do a reciprocal, right? We just switch this one top and bottom, switch this one top and bottom, and then you are going to look at the left hand side and the left hand side multiply, okay, as well as the right hand side and the right hand side multiply. So what is it that you end up with? You have you 9 over 4 y raised to the power 3 over 4 z raised to the power x raised to the power 3 over 4. This one equals to the lambda, okay, using f sub x. But then this one, the 4 y raised to the power 1/4 27 y raised to the power 1 x raised to the power 1/4. Okay, this is x. This one equals to 1 over lambda. Okay, 1 over lambda. Then all the 4 cancel. This one is a 3, and your y combined to be just a single y, and then 3, your x also combined to a single x. This one is 1, so it means that for this one y is actually 3x. Okay, so where else can we find the relation among the y and the x? Of course, it is the constraint, right? This one. So you know that your x and your y together must be 60,000, but right now your y is simply 3x. Okay, so it means that your 4x, it is 40,000. So your x is simply 40,000 over 4. Okay, so this is what, 415, right? So your x must be 15,000, so right, and of course your y 45,000. Okay, so together you obtain 60,000 as a advertising budget. Okay, this one at first actually it is a critical point, right, of the profit under the constraint. Okay, x and y equals to 60,000. However, it's saying here that the critical point is actually correspond to the maximum profit. So it means that this point, okay, when your x is 15,000 and your y is 45,000, will give you the maximum profit under the budget constraint as well. Okay, so that will be pretty nice and easy problem, right? Okay, so you just figure it out how to solve for x and y after you do the partial derivative of the capital F. Okay, so let's look at another example. It says that a consumer is to buy products x and y at the price px equals to 2 and py equals to $3. Of course, this one is the price per unit, but they have the fixed budget of 48. Okay, so it means that if your x is the amount of the x product, your y is the quantity or the amount of the y product. Okay, so if you buy one of the x, you pay $2. Okay, but you buy x of the x unit of the x, you have to pay 2x. You buy 1 unit of your product y, you pay $3. But of course you buy a small y units of the product y, you pay y dollars. Okay, together cannot beyond your budget. Okay, but we are going to again finding some kind of maximum, right? Some kind of maximum. So we are going to spend all the budget. Okay, so all what you need to find is to find, of course, the quantity of each product. So to find your small x and y that we should buy, so that it allow a maximum satisfaction. Okay, so the satisfaction is measured by the so-called utility function, and this is a utility function. Capital U depends on x cube and y cube, just like this. Okay, so it is again the problem of finding a maximum under this constraint. Okay, so let us rewrite our constraint a little bit. So we got 2x 3y and 48 equals to 0. This one is actually your small f, okay, in the general context. So what we need to do is to find your capital F, which is your small f minus lambda of your constraint. Okay, and then all what you need to find is the critical point, okay, of a small f, or right now it's a u. So you find f sub x, which is 3x squared y cubed minus 2 lambda, and f sub y, it is 3x cubed y squared minus 3 lambda equals to 0. You see 3 lambda, and this one 2 lambda, and f sub lambda, it is simply your constraint again with negative sign, and you make it equals to 0. Okay, so now I mean this one again depends on how good your algebra is. So your f sub x, you may notice that it is this one with a 2 lambda, and your f sub y, it is simply 3x cubed y squared equals to 3 lambda. You may see that, hey, I mean on the left hand side and the left hand side here, they are almost the same, right? But this one on top, they're missing one x. This one at the bottom, they're missing one y. Okay, what is it that we can do? One of the things that we can do is we can do the division. Okay, so you are going to say that, okay, this one is on the top, and then this one is on the bottom, right? So they must be the same again, but they happen to be cancelled your lambda. Okay, your lambda is I mean on your right hand side is 2 over 3, and this one also happen to cancel several x and y, right? For example, this one, the x square cancelled, the y square cancelled, so you have y, and the 3, of course, you have y over x. Okay, so it means that actually your y is 2x over 3. Okay, so can you solve for x and y further? Of course, I mean we can go back to this constraint, right? Because it contains only x and y here. So let me just add one of the pages just in case. So you have 2x, and instead of 3y's, you got 2x over 3, and then equals to 48. So the 3 and the 3 cancel. You end up with 4x equals to 48, or your x, it is 12. So as your x equals to 12, you can use this relation to get your y to be 8. Okay, so what does this mean? The 12 and the 8, this is your critical point of the utility function under the budget constraint, right? Under the budget constraint. However, as we told you that this critical, okay, you got only a single critical point, and you need to find the maximum. This one will correspond immediately with your maximum utilities. Okay, so it means that this one will give a maximum satisfaction under the budget condition. Okay, so you need to buy 12 units of x, 8 units of y, so that it will maximize your satisfaction. Okay, so if you want to know the what's the level of satisfaction, you just replace your x by 12 in here and your y by 8, okay, to find a value of your capital U. We get? All right. So let's look at this one, and the good news is that this example 7 will be the last example of this chapter. Okay, So it says that Mr. Lee and Mr. Kim are shopping for shirts, okay, for which there are two brands to choose. The first brand will cost 500. However, the second brand, of course, will be cheaper, cost 300. Okay. And the satisfaction function of Lee and Kim, they are different. For Lee, okay, this one is for Lee, it is xy equals to k, and for Kim, it is xy squared equals to k. Of course, your x and y is the amount of shirt for the first brand and the second brand respectively, okay, and the k is the level of satisfaction. Okay, so that your small case like a capital U in the previous example. So if the budget of Mr. Lee is only 6,000, how many shirts of each brand should he buy to allow the maximum, again, a maximum satisfaction? Okay, so this one is not that difficult. You just use the same technique that we did with the previous example, right? What's the constraint? What's the constraint? The constraint is that if you buy only one shirt of the first brand, you pay 500, right? But you are going to buy X one of them, so you have to pay 500X. And if you buy one shirt of the second brand, you pay 300, but you are going to buy for Y of them. So this one added together cannot go beyond 6,000, but you are going to maximize your satisfaction, so you just spend all your money. Okay, spend your money. So it means that your constraint gxy, it is 500x, 300y, and minus 6,000 equals to 0. Okay, so what is your capital F? Your capital F, it is the satisfaction of Mr. Lee, right? So let's say, let's just use the small k minus lambda 500 lambda g. So this one, your k is xy minus lambda of 500x, 300y, and 6,000. So your f sub x, it is simply y minus 500 lambda, and your f sub y, it is simply x and minus this one 300 lambda equals to 0. Okay, so this one, it depends on like what you need to do. Okay, so you may say that, hey, this one we can solve for y in terms of lambda, we can solve for x in terms of lambda, and then you just plug into your f sub lambda, which is your constraint, right, with a negative signs, make it equals to 0, and then you can just plug in these two into this equation, or you can just simply use the technique that we did before. Okay, so this one, it is y equals to 500 lambda, while your x equals to 300 lambda. So you just simply do a division. You see a division, then the lambda is gone, so you have a 5 over 3. So it means that your y is simply 5x over 3, and you're going to just immediately plug in your y into that constraint to get your x. So you have 500x and 300, 5x over 3 must be equals to 6,000. So this one, of course, you have 1000x equals to 6,000. So your x, it is a 6, and your y, I mean, you just plug in here, it is a 10. So to maximize the Mr. Lee satisfaction, you will buy your first brand for 6 units and the second brand for 10 units. Okay, and then you can figure what is the maximum satisfaction. So this one will give a maximum satisfaction. Okay, for Mr. Lee. Are we all right? So let's take a look for the second problem. It says that if Mr. Kim now have only 45 hundredths, okay, so it means that for Mr. Kim, the constraint, okay, the constraint change, okay, into the you remember how much for the first brand, 500x and 300y, but now he has only 4500s. And the satisfaction, I mean the capital F now is the K for Mr. Kim, right, minus lambda of the G of Mr. Kim, and here's the G of Mr. Kim. So your K for Mr. Kim, it is a little bit different. You got xy square, and then minus lambda, your G is simply 500x, 300y, and minus 4500s. Okay, don't forget this one must be moved, okay, so that your right hand side always 0. So your f sub x, it is what, y square minus 500x, 500 lambda, you see, make it equals to 0. Your f sub y, it is 2xy minus 300 lambda, make it equals to 0 as well, you see 300 over there. And your f sub lambda, it is simply your constraint with a negative sign, okay, make it equals to 0. Alright, again, this one depends on how good your algebra is, okay. So you may say that, hey, this is a y square equals to 500 lambda, and then divided by 2xy, which is equals to 300 lambda. So all the lambda is gone, right? Okay, and then one of your y cancelled. All right, so it means that or what you end up with y on top over 2x equals to 5 over 3, or your y is equals to 10x over 3, and you can just replace your y into your constraint, okay. So you have 500x and 300 instead of y, you have 10x over 3 equals to 45 hundredths, okay. So this one, it is 110, so it is 1500x equals to 45 hundredths, okay. So your x is 45 over 15, which is 3. Is it? So as your x is 3, then you know that your y here is simply 10, okay. So this is, of course, at first it's a critical point, okay, for a small k of Mr. Kim under his budget constraint. However, this one again will correspond to the give the maximize satisfaction, okay, for Mr. Kim, okay, for Mr. Kim under the budget condition, okay, under this kind of budget. Are we all right? This is a straightforward questions, okay. So of course, I mean, if this is the budget of Mr. Lee, right, as previously, and this one is the budget for Mr. Kim, who would get more satisfaction, okay, who would get more satisfaction? So you need to find your k of the Lee, okay, which is x and y, and for x of Lee you need to go back to your first problem, which is 6 and 10. So you got 6 multiplied by 10, which is 60 as the level of satisfaction. But the k for Mr. Kim, it is xy square, is it? Just go back. You see, xy squared is k for the satisfaction level for Mr. Kim, and here his x is 3 and his y is 10, so you have 300s. So I mean this one get more satisfaction at the same level. I mean not same level, at this budget, okay, for his budget, okay, even though his budget is less than Mr. Lee budget, but after we do the calculation, we know that the Mr. Kim satisfaction is more than Mr. Lee satisfaction. Okay, can you see the level of some different? Here is y, there is y squared, and your y is the product that is cheaper than the x. Remember, the y is 300 per unit, the x is 500 per unit. So I mean, for Mr. Kim, he look like he prefer to buy a cheaper one, you see. But for Mr. Lee, it look like the cheaper or the more expensive, it doesn't matter. He like both of them like at the same level, okay. But Mr. Kim, he like the cheaper one more, so that's why he satisfy more. Okay, all right. So we hope that you guys will go over several word problems, okay, because the word problem will be the one that we emphasize on, okay, and try to solve this kind of word problem using, of course, the Lagrange multiplier, or using just the finding a critical value and the second derivative test if we don't have any constraint or any condition. Okay, so we'll see you during the final exam or any other venue of this course. Bye bye.